Hey, welcome guys. So it's chapter 20 on air pollution, the second to last chapter of the year. And this is our lecture number 1. So the objectives here will be to review the atmospheric layers and composition. That's the information we learned back in chapter 5, but I thought it'd be important to address that one more time. We're going to differentiate between primary and secondary air pollutants, and then also identify major classes of air pollutants and their associated sources and health concerns. We're going to try to move through this relatively quickly, but the accompanying reading is from the textbook, pages 452 through 457. All right. So as a reminder, so getting back there in chapter 5, we did talk about the composition of the atmosphere. So we're running close to 80% nitrogen, about 20% oxygen, and then argon, carbon dioxide, other trace gases make up the remainder of the atmosphere. So primarily nitrogen and oxygen. And some important things about the atmosphere: regulates climate and weather, cycles nutrients in and out, redistributes water in the hydrologic cycle, blocks ultraviolet, so the nasty types of radiation that come from the sun. Most of that gets blocked by the upper atmosphere, thank God. And so, again, this is just a review of some of the stuff we talked about back in chapter 5. All right, and then our layers of our atmosphere. Okay, we've got the troposphere, which is where all life exists and all weather occurs. The stratosphere, which is where we have that protective ozone layer. Then we have the mesosphere and the thermosphere, right? It might be helpful to go back and review those layers, try to memorize them. A little mnemonic I use is TSMT, and then of course, not shown in here, we have that exosphere, which is basically where the atmosphere just slowly thins out into space. So TSMTE. So the mnemonic I use is true scientists measure things. All right. So maybe that will help you guys remember those layers a little bit. True scientists measure things. All right. So first of all, when we talk about air pollution, we are talking about chemicals that are added to the atmosphere by either natural events or human-caused events. Of course, the things we're primarily concerned with would be those human sources of pollutants, but volcanic eruptions and wildfires, which are naturally occurring events, also contribute to air pollution. All right. Our two primary categories for pollutants are primary air pollutants, and those are the pollutants that are emitted directly to the atmosphere, so as they are, okay? And then we have what are called secondary air pollutants, which are pollutants that are created through chemical reactions between primary air pollutants, okay? So for example, a primary air pollutant might be sulfur oxides, right, that come from coal-burning power plant, or from a smelting facility. All right, those sulfur oxides would be a primary air pollutant. Now, they will undergo often reactions in the atmosphere and dissolve into water to create sulfuric acid, which would be a secondary air pollutant. Okay, so the primary pollutant would be sulfur oxide. That's what's directly emitted to the atmosphere. Secondary pollutants are created through chemical reactions that occur in the atmosphere to form a secondary pollutant. All right. So here are some examples of our primary air pollutants that come through usually some sort of form of combustion, okay? And then their associated secondary pollutants. Most of our acid precipitation is the result of secondary pollutants. All right. So our major classes of air pollutants, which are regulated by the Clean Air Act, which is one of those big 3 environmental legislation. Again, Endangered Species Act, Clean Water Act, and Clean Air Act are our big 3. Okay, so these are the various classes of air pollutants that are regulated by the Clean Air Act. All right, and we will talk about each of those in turn. So particulate material, and this again is something we're all familiar with around here because just this, the fall of 2017, many of you guys will remember that we had lots of warnings out about the air quality. All right, so particulate matter primarily comes from combustion, and in the case of a wildfire, we can have a huge spike in particulate matter. Now, So soil particles, so if it's excessively dry and we get a big windstorm, those dust storms, we have particulate material pollution. Soot from fires, okay, lead or asbestos actually, which are troublesome inside. Those are all considered particulate materials, so liquid or solid particles that are suspended in the air. And generally, the smaller those particulate particles are, the more harmful they are. All right, and they are dangerous because they could be toxic or carcinogenic, things like asbestos and lead, or because they're extremely small and suspended in the air, they can actually become lodged in your lungs and cause things like asthma or other sort of respiratory irritation. So nitrogen oxides and sulfur oxides. So these are gases produced typically during some form of combustion. All right, our nitrogen oxides are gases produced by chemical interactions between atmospheric nitrogen and oxygen at high temperatures. You guys should have read about that interaction in class when we talked about the Volkswagen controversy. Okay, so the problems with nitrogen oxides is they are greenhouse gases, so they contribute to the greenhouse effect. They are a respiratory irritant and can cause difficulty breathing. They contribute to photochemical smog and tropospheric ozone formation. All right, our sulfur oxides, right, are produced by interactions between sulfur and oxygen, and their primary concern is that they cause acid precipitation. And I apologize, that's a little bit cut off there. That says acid precipitation at the bottom. That is their primary concern. And we will talk more about the effects of acid precipitation at a later time. Carbon oxides and hydrocarbons. So carbon oxides are combinations of carbon and oxygen. Carbon dioxide, just FYI, not addressed under the Clean Air Act. Okay? As of right now. Carbon monoxide, on the other hand, is addressed by the Clean Air Act. So there are limitations in the amount of carbon monoxide they can form. Carbon monoxide happens when you have incomplete combustion. So it's primarily an indoor concern in terms of how it directly affects health. Outdoors, it's a primary pollutant that can contribute to photochemical smog, which again we will talk about later. And carbon oxides are, of course, greenhouse gases as well. All right. Hydrocarbons are combinations of carbon and hydrogen. They're often volatile, can be greenhouse gases. So, for example, methane. And some of those hydrocarbons are also related to photochemical smog. Ozone. So we need to make a quick differentiation between tropospheric and stratospheric ozone. In the troposphere, where we live, ozone is considered a pollutant, right? Even though it is necessary to sustain life up in the stratosphere, down here in the troposphere, we don't want to breathe this in. It's a very volatile compound. It's O3, right? And the structure of that ozone makes it very reactive and volatile. It can cause respiratory irritation, eye irritation, and also it's a greenhouse gas. And it contributes, again, to this word, photochemical smog, which, like I said, we will talk about later. Okay. In the stratosphere, though, right, that ozone molecule that we consider a pollutant down here in the troposphere is extremely important because it blocks out things like ultraviolet radiation. All right. And we'll have a special lesson about the stratospheric ozone a little bit later, okay, along with our discussion of photochemical smog. So right now, we're just going through the different classes of ozone and their basics, all right? Moving forward, sources of outdoor pollution. Transportation sector in the industrialized world is the primary cause, all right? Take that in combination with fuel combustion, and industrial processes. When you take all those into consideration, the vast majority of air pollution comes from the combustion process, whether it's done for transportation or for electricity production or for heating of homes and houses. The vast majority of our air pollution comes from some type of combustion. All right? So forest fires, of course, during certain times of the year can contribute, but then again, forest fires are combustion. All right. So sulfur dioxide and particulate material, they irritate respiratory tract and they impair the ability of the lungs to exchange gases. All right. So even though you might be breathing air in, your lungs might not be exchanging oxygen and carbon dioxide as well as they would be. All right. Which can lead to low levels of oxygen in the blood, headaches, dizziness, nausea in some cases. Nitrogen dioxides tend to cause airway restriction. They tend to irritate the respiratory tract and cause inflammation to mimic asthma-like symptoms. Carbon monoxide, extremely dangerous because it bonds with your hemoglobin. Hemoglobin is responsible for transferring oxygen throughout your body. So what happens with carbon monoxide, usually only a problem indoors, by the way, where carbon monoxide pollution can become a high enough concentration, is it goes unnoticed. So essentially what happens when there's overexposure to carbon monoxide is you get drowsy and you essentially just fall asleep and then you die, right? Which is why if you have any sort of natural gas heating or cooking in your house, you should have a carbon monoxide detector. That is code and required in all buildings these days. All right. But again, it's a slow, unnoticed situation where you just become tired and you fall asleep and then you die. All right. So carbon monoxide, of course, very important to regulate. And then things like ozone cause burning eyes, coughing, chest discomfort. All right. Children, by the way, are more susceptible to all these things because their rate of respiration, they're breathing in and out at a much higher rate than most adults do. All right. And of course, they're still in the process of developing their lungs, and it can restrict that development in children. All right. There's a strong correlation between children who live in high ozone areas and the development of asthma. All right. I promised this would be less than 15 minutes, so that is it.